So in this class, I will explain the concept of simple welds which are used to connect a member with a gusset plate or two members. So in the case of welded connections, just like the boarded connections which I have done earlier, the two important parameters are the length of the weld and the size of the weld. So whenever you are asked to design a weld, you have to find the thickness and the length of the weld. So for that, you have to refer the pages 78 to 83 of IS 800 for welded connections. So you have to understand certain terms before going for the problem. Design strength of fillet weld, of course, it is given in that page 78. FWD is equal to FWN by gamma MW. So where FWN is given by FU by root 3, and if you substitute that here, so FWD will be FU by root 3 into gamma MW. This gamma MW is the partial safety factor which depends on the type of weld, whether it is a sharp weld or a side weld. So if it is a sharp weld, gamma MW is 1.25. If it is side weld, it is 1.5, which is given in table 5 of the course page 30. Area of weld is calculated, AW is calculated by multiplying the effective length of the weld LW and the thickness of the weld. Thickness of the weld is given by 0.7 times the size of the weld. S is the size of the weld. So this actually this 0.7 is a constant K, which depends on the angle theta between these two surfaces. If this is the weld, the angle between these two surfaces is theta. If the angle is between 60 to 90, the value of K is 0.7. So normally in most of the cases that value is between 60 to 90. It is there in table 22. So this value is available in table 22, page 78. Page 78 of the code, whereas this formula is available in page 79. Yes, here one important thing is the size of the weld should not be less than 3 mm. Once again, these are all the specifications given. And this, of course, size of minimum size of the weld depends on the thickness of the plates or the sections which we are going to connect. Normally, we use 5 mm, 6 mm or 8 mm welds. So these are called as fillet welds. So they are divided like this. So sometimes we are going to use one term called end returns, whose length is normally taken as 2s, or it should not be greater than 2s, or it can be equated to 2s, where s is the size of the weld. So this is the LW, length of the weld. End return is provided at the corners here to transfer the load. So that is taken as minimum 2s. So therefore, from this stress value, this design strength of fillet weld in terms of stresses in Newton per mm square, you are going to get using this formula. When this is multiplied by the area of the weld, you are going to get what is called as the design strength of weld. So this normally is expressed in newtons or kilometers. So whenever you are asked to find the design strength of the weld, you have to use this formula PdW, which is given by the product of FWD and AW. Once again, FWD is given by this formula, FU by root 3 gamma MW. FU can be taken unless it is given, you can take it as 410 Newton per mm square. Gamma MW, of course, it depends on the type of weld, whether it is sharp weld or side weld. Once you know LW or T, you can find out this design strength of weld. Now let us take some simple problems on fillet weld. So what we are discussing is on fillet weld, which is the mostly used weld type. Now I will take up a problem wherein you need to compute the so I will take this problem. You are asked to find the design strength of the weld in these cases. Find the design strength of fillet weld shown. Okay, now let me take the figure like this. Here he has given a plate. This is a plate. The plate runs like this in this direction. This plate is connected to a gusset plate. So like this. This is the gusset plate. It runs in this direction, opposite direction. So the weld is provided here. This is how the weld is designated. So this is provided like this. Weld is provided like this. And of course, some delta is also given. So this length of the weld is 75 mm, whereas this is also 75, and this is also 75. Now the question is, if suppose if the size of the weld, if the size of the weld is taken as 6 mm size. Weld size is 6 mm. That is S value is 6 mm. Now the question is, we have to find out the design strength of the weld, that is PDW value for this. PDW. So we have this formula, PDW is equal to FWD into AW. Now simple, there are only two steps here. So what I will do here is, first I will calculate this LW, length of the weld. So length of the weld, here you can see that this welding is done on three sides, 75, 75, this one 75. So total will be 3 times 75, length of the weld is 225. So you need not take this generator. Generator you need not take. Next, thickness of the weld is given by 0.7 times S. S is the size of the weld. Here size of the weld is 6 mm. So 0.7 times 6, so it is 4.2 mm. So when you multiply these two, you are going to get the area of the weld. Area of the weld, AW, is LW into T, 225 into 4.2. So this becomes 225 into 4.2 equal to 945 millimeter square. 945 millimeter square is the area of the weld. Now we have to calculate this FWD. FWD is the design stress of the weld, or design stress in the weld, you can say, which is given by this formula, Fu by root 3 into gamma MW. Now let us assume that it is shop welding. Welding is done in shop under controlled conditions. So gamma MW we have to take 1.25 for shop welding. So F2 is 410. So if you substitute 410 divided by root 3 into 1.25. So this is the value of FWD. So let us calculate that. 410 divided by root 3 divided by 1.25. So you are going to get 189.37. 189.37 Newton per millimeter square. This is the value of FWD. Now therefore PDW, that is the design strength. Design strength of weld, PDW is equal to FWD into AW. So which is given by 189.37 multiplied by 945. So this will be in newtons, because this is newton per mm square, this is mm square. So you will be getting in newtons. So you will get the value as design strength of the weld. That means this weld can carry a load up to 178.955 kilograms. Now suppose if it is side welding or field welding, we can also call it as field welding. In that case, gamma MW is 1.5. So there will not be any controlled conditions under welding. So PDW in this case will be, once again it is PDW will be FWD into AW. Here, what happens here? FWD is nothing but W by root 3 into gamma MW. This into AW is LW into the same. AW remains same, only thing is gamma MW is 1.5. So 410 divided by root 3 into 1.5 instead of 1.25 into LWD is AW remains same, that is 945. Once again, this will be in newtons. You can convert it into kilonewtons. So 410 into 945 divided by 1.5 divided by root 3. So 149.13 kilonewtons. So this is the strength of that weld if it is done in field. So same member under different conditions. If it is welded at shop, it can take more load. If it is welded at site, it can take slightly lesser because welding is not done under controlled conditions in the field. So this is how we can conclude the design strength of weld. If the length, the thickness, all those things